All right, so welcome back after our kind of break from EU. We got to get back into it, as you know, and we're getting close to fall break, but you can push through, you can make the good choices, and do the right thing. So this right here is your welcome work that you should have grabbed next to the purple basket. Make sure that you have that filled in, filled out, and then it gets turned into the correct class. All right? So if you need to pause it, fill it out, and then come back, do so. So this is now in the actual packet that you got, all right? It says right here, a palindrome is a word or phrase or a sequence that reads the same forward or backwards, all right? So there are some easy ones, there are some harder ones. So the first one we're going to talk about is race car, right? R-A-C-E-C-A-R. If I put that backwards, right, this R comes from here, this A comes from here, this C comes from here, so on and so forth. It's the same forwards as it is backwards. Another one is the phrase taco cat. Taco cat. Taco cat. All right? Another one is the word poop. P-O-O-P. All right? I, like your eyeball. All right? E-Y-E, backwards is E-Y-E. Mom, those are a couple easier ones. Noon, like the time of day. And then the last one that we have on our list is the name Hannah. So again, if I spell it forwards or backwards, it gives us the same exact word. All right? That's what a palindrome is. Okay? Now, obviously, you're not in an English class, so we're going to relate this to math. So if you look at this, 3 plus 5, does that answer give you the same answer as if you did 5 plus 3? Yes or no? Yes. So that statement is true. 8 does equal 8. Good. 2 plus negative 2. Well, this is a positive. This is a negative. They're both the same number. So they cancel out and give me 0. So that is, in fact, true. What is 6 minus 3? 3. What is 3 minus 6? Negative 3. So that is false. That is false. If I add 5 and 0, do I get 5? Or do I get 0? Well, I'd get 5, and this says 0, so that one is also false. All right? There we go. Now, 2 plus 4 plus 5 equals 2 plus 4 plus 5. But, like, those parentheses are moving. Okay? So let's make this easier. I'm going to add what's in the parentheses first, right? So this would be 2 plus 4 plus 5 equals 9. 2 plus 4, 6, and then plus 5. What's 2 plus 9? 11. What's 6 plus 5? 11. Does 11 equal 11? Yes, so that is true. Try and do B and D and come back to me. Try and pause the video, try and do B and D, and then come back to me. Welcome back! You should have gotten true and false. You should have gotten true and false. All right? Turn it over to the next page. These are just properties, so I'm just going to have you fill in the words. Additive and multiplicative. Additive, you see the word add, so it just means they're being added. Multiplicative kind of looks like multiply. That's what they're doing here, okay? So a lot of times they'll just talk about identity properties. They won't actually talk about the specific kind, which is okay. All right? The next two, the numbers are moving, right? They're not in the same order as they were before. This is called the commutative property, right? So they're commuting. Think of you commute, right, from your house to school. You commute from your house to work, things like that. So you're going from one place to the other. So the 7 started out in the front, now it goes to the back. This 20 started out in front, now it goes to the back. Okay, so you're commuting. All right, now for the next one, Do you see how these parentheses are around the 9 and the 4? And then they're around the 4 and the 17. So the numbers aren't moving. The parentheses are moving. So when you're in a group of people, those are your friends, right? Somebody might say, oh, that's who so-and-so associates with. So this is called the associative property. Associative property is when what's getting associated together, right, in those parentheses, gets moved. Just like y'all, you have different groups of friends, or you have one friend, you know, when you're at your house, but then you have a different set of friends when you're at school. Okay? Now, the last two are called the additive inverse, just like on our welcome work, right? You add the same number, different signs, so that equals 0. Or when you're multiplying, you have reciprocals of one another, and that equals 1. All right? So make sure you get those down, and then if you need to pause it, do so and come back. All right. So looking at the bottom of that page, this is the same letters, but they're moved, right? They're commuting. All right, so we're looking at either a property of a commutative property of addition or multiplication. So what sign is this? Adding. So you should have commutative property of addition. And if you want to, you know, shorthand that to be initials, go for it. This one, the letters are not moving, but the parentheses are moving, right? So what's that going to give me? That's the associative, right? What's being associated together is what's moving. All right, and then this one, a number times 1 always equals that number. So that's kind of like your identity, right? My identity is not changing, even though I'm multiplying it by somebody, by 1. My identity is not changing, even though I'm adding 0. And then a number times its reciprocal, right? That's this down here. So that's that multiplicative inverse property. So let's try a couple. 5 times 1 equals what? 5. So would that be commutative, associative? So remember, commuting is the numbers are moving. Associative is the parentheses are moving. Identity is when that number is staying the same, right? Our answer is the same, or creating a 0. So this is going to be the identity, right? The identity that 5 is not being changed even though it's being multiplied. So 12 times what equals 12? 1. So what property is that? It's that identity property again. Okay? 4 times 9 equals 9 times what? 4. Good. So what's moving? The numbers. So is that the commutative or is that the associative? That's the commutative, right? Commuting, moving. 30 times what equals 50 times 30? What numbers moved? These two both moved. So they commuted. All right? 8 times what equals 0? 0. So what is that? The 0 property. Good. Why don't you try doing 6 through 10? Just try it out. See how you do. Pause it. Come back to me. Welcome back. All right, so in this one, you should have our associative, our parentheses moved. In 7, you should have associative again, the parentheses moved. In 8, you should have associative again, the parentheses moved. And in 9, you should have commutative because the numbers moved. All right, going on to the next page. A term is a number, a variable, or a product or quotient, multiplying, dividing. So there are 4 terms in this expression. You have, oopsies, let's do this, 2x, you have negative 4xy, or 4y, I'm sorry. You have 7z, and you have 3. Each of those are its own separate term. So I always tell students, think of it as whenever you see a plus sign or a minus sign, that's when it's a new term. Okay? A variable, as you know, is typically a letter, so we're going to call it a symbol, right? We could say x, we could say y, we could say z. There's a ton of other symbols that we could use. A coefficient is the number in front. It is multiplied by the variable. So the coefficient here would be 2. It's being multiplied by the x. The coefficient here would be that negative 4. It's multiplied by the y. The coefficient here would be 7. It's multiplied by the z. The coefficient here would technically be 3, even though there's not a letter next to it. Okay? So 3 is actually called a constant. And a constant does not change, and it does not contain variables. It does not change, and it does not contain variables. When we can add like terms or put like terms together, they have to have the same variable and the same power. They have to have the same variable and the same power. If you need to pause this and then come back with me, that's perfectly fine. All right, so we're going to do the bottom part together because this one's a little bit harder. So this is the term a cubed. I know you cannot see any number in front of that a, but I'm going to tell you that there is one. And that number in front of a is the number 1. Then this with the variable, because they want the whole part with the variable, we're just going to put that whole daggone thing. So we're going to put a cubed. All right, now this next one, I have negative 3a squared b. The coefficient is the number in front, and we always want to make sure we take the sign with it. So that's negative 3. And then the variable part is everything that's left, so a squared b. All right? For this one, the coefficient, the number in front is 3. The variable part is that ab squared. This one's kind of like the first one, right? You don't see that number there in front. It's kind of awkward. So what is it? It's negative 1, and then b cubed is all the variable part. So come back to me in a minute, pause this video, and see what you get for this part. Welcome back. You should have 3 for the coefficient, x squared for the variable part, 5 for the coefficient, xy for the variable part, 9 for the coefficient, y squared for the variable part, 12, the whole number 12 is the coefficient. There is no variable part, so if you left that box blank, that's perfectly fine. If you want to put none in, that's perfectly fine. So take a minute, pause the video, get that written down, and then come back with me. All right, we've talked about this before. You can only combine terms that have the same base and the same exponent. You will hear that again and again and again. Okay? All your answers should be arranged in A, B, C, or alphabetical order, and then from greatest to least with the exponents. So looking at this one right here, see how this 14m and this 3m are in red boxes, and then these n squares are in circles? That's because they're different. I can combine the things in red boxes and I can combine the things in blue circles. So we're going to go in alphabetical order, so m is before n. So what right here, this 14m represents 14 m's, right? And then if I add 3 m's to 14m, I get 17m. Then I have negative 3n squared minus 2n squared. Those are both negative numbers. I'm going to add them together. That gives me negative 5. And then I just keep my base as is. You do not want to square your 3, and you do not want to square your 2 because those squareds are on the n only. So if we do the same thing here, I'll kind of do it a different color to make it easier. If I circle my 5x, what is like my 5x? My 4x, good. And then what is my minus 6? Is that different or the same? Different, good. So I'm going to put a square around that. And then what about this 5x squared? Is that the same or is that different? It's actually different, so I'm going to put a little cloud around it. All right? So let's start. What's going to go first? My greatest exponent. So that's going to be my 5x squared. I don't have to add, subtract anything to that. That's what's awesome about it. Then, what's 5x's plus 4 more x's? 9x's. And then I just have my minus 6. Done. All right. Like I said, we're going to keep saying it. You can only combine terms when the variable has the same exponent. You can only combine terms when the variable has the same exponent. You should always put the variables of your answer in alphabetical order, ABC order. Then my exponent. You should always move the negative signs along with a term. Just like I did here, right? I circled the sign in front of it. Just like we did when we were doing our integers, and we circled the whole thing, including the sign, to help us to know whether or not the number was a negative or positive. Okay? So, turn it over to the next page. This is a fun one. Looking at the number or the letter Y. In here, we are looking for anything that has a Y. Not a y squared or y cubed, because that's different. That's not the same exponent as a y. So the things that are like y would be y, right? What else? 9y. There's actually 2 of these, right? There's one here and there's one here. 3y. And there's one more, 11y. Okay? Next one. Let's do x squared. So where do you see any x squareds in here? Well, there actually is another x squared. There is a negative x squared. And what's my last one? 6x squared. All right, let's skip 8. Let's look at z. What are some z's? We got 2z. We got 7z. 4z. 2z. And we have a 5z. All right, and again, if you did that by yourself, that's perfectly fine. What could I go with the 8? 11, 7, and 19. All these just plain old numbers can be combined with my 8. These 4 left over, they're different. The only 2 that I could put together here would be these 2. Everything else can't be combined with anything else in the trees, which is perfectly fine. All right? So looking at the very bottom of that back of the last page, I want you to do this right here. I want you to do this right here.